It's important for technicians to understand two electrical terms: electromotive force, or EMF, and counter electromotive force, or CEMF. Remember that EMF is the force which moves electrons through a circuit. It is commonly called voltage. When we apply current to the armature, it rotates as it interacts with the field. However, as it rotates, it cuts across the flux lines of the field coils. This in turn induces a voltage in the armature. This voltage is the opposite polarity of the voltage present in the armature. This is known as CEMF. CEMF in the starter prevents motor burnout by regulating the current through the motor. If the motor stalls, the low resistance of the windings will permit a huge amount of current to flow through them. However, because the armature rotates, the CEMF which is developed limits current to the armature. The faster the armature rotates and cuts through the flux lines, the higher the CEMF that's produced in the armature. The maximum torque is produced in the motor at low armature speeds because there is little CEMF produced. This also makes series-wound motors so powerful. As the load increases and the armature begins to slow down, the amount of CEMF is also reduced. This allows a larger amount of current to flow, and the torque of the motor increases. The shunt winding, by maintaining a constant magnetic field over the armature, produces a high CEMF in the armature when it rotates too fast, thus acting as an overspeed control device. The electric starter motor is one of the most important components on the automobile. It is a rugged and reliable unit that does its work repeatedly during the life of the automobile. In the next video, we will look more closely at the components of the starter motor.